Hello, everyone. My name is John Zaccone. I'm a developer advocate at IBM. Really excited to be speaking at the virtual hackathon for Call for Code. Right now, I'm broadcasting from Richmond, Virginia. So I took the snapshot of Florence yesterday. In Richmond, we're going to get a lot of rain. We're missing a lot of the heavy stuff. So we're thankful for that. But also at the same time have lots of friends and family in North Carolina and the Carolina coast that are impacted by Florence. So it's kind of crazy to be kind of talking about Call for Code, talking about technology, and we have real life events happening, right outside our windows. So pretty excited to be kind of as a developer in a position to being able to make an impact on something like disaster preparedness and natural disasters. And that's something that I'm definitely pretty excited about. So, today we're talking about that junction of natural disaster preparedness with technology. And the technology that I'm going to talk about today is Kubernetes. I'm a developer, so we're going to dive kind of into the architecture of Kubernetes, understand how it works, and we're going to see a demo of it a little bit later on, and then show you guys, if you guys want to get started, we'll have a really easy way for you to pick up where I left off today and do stuff on your own. So the one-liner for Kubernetes is that Kubernetes is a container orchestration platform. And before you move to Kubernetes, typically you start your conversation or you start your journey with using Docker containers, because that's what Kubernetes is built on top of. There's a lot of good advantages for using Docker containers by themselves. Here's quite a big list here. But one of the biggest things that comes to my mind when I think about disaster preparedness applications is portability. Think about if you're preparing or you're writing these applications to handle problems of disaster preparedness. Where do your applications need to run? Do they need to run on the cloud? They need to run on a local workstation setup that you might have deployed on the field, IoT devices that are collecting data out in the field. So if you have applications that need to run across these very, very different environments, portability is a huge thing that you're going to want to think about. Your application has dependencies, and you don't want to manage all of those dependencies, set up each of those systems individually. You want to use something like Docker, and with Docker, all of your dependencies are self-contained, and assuming that you have a Docker engine running on all of these environments, you can basically deploy the same built image across these environments, and your application will run, and it will run the same way in every environment. So the way that this works is that Docker containers run in isolation. They are isolated from dependencies on their system. So let's say you have a Java application or a Node application, and you don't have Java installed. Maybe you have a different version of Java installed. It doesn't matter. On the system, on the underlying system. It doesn't matter what you have on the system. Those containers are going to run in isolation, and those dependencies are going to be explicitly defined within that container. How do you explicitly define dependencies? We do that with a Docker file. And we'll show some examples of that in the demo today. So the benefits of containers doesn't stop with just using containers, although there's a lot of reasons why you'd want to use containers, portability being kind of a crucial one. But you also have this advantage of this standardized interface, which comes with this container. So the shipping container analogy is that you can put anything you want in a shipping container, and that container is compatible with trains and cranes and ships and all sorts of mechanisms to transport these containers to different locations. The same, extending that to Docker containers. You have different types of applications packed inside of these containers, and once you have them inside of your containers, use the standard Docker interface to run and deploy these applications. So why should we care about this standard interface? Well, the standard interface enables a whole suite of tools to be built on top of that interface. We can solve problems generically. We can solve problems in a language agnostic way, and that's what Kubernetes is really does. Is it does container orchestration, and you can use Kubernetes with any types of applications that you might be running inside of your Docker containers. So using something like Kubernetes unlocks what I like to call the next level of containers. You have all these problems that you maybe didn't necessarily knew that you have, but let's talk about a couple of them. Scaling to demand. One of the use cases that comes to my mind when thinking about disaster preparedness is if you have intermittent internet connectivity. Maybe you're receiving data in the front end, you're receiving requests, and you're queuing those requests up, waiting for an internet connection to come back into connectivity, and then you're going to handle all of those requests in batch at one time. So you could think of that as a scaling scenario. You have to scale up quickly to handle those that incoming surge of requests, and then scale back down again when that is no longer needed. You can also think about this as different timelines throughout a disaster scenario. You're definitely going to have kind of peaks of need for your applications at different times. Ensuring your applications are always working. Companies are all about making sure 100% or 99.999% availability of their applications, making sure they're always up. And in a kind of a enterprise like e-commerce world, having your website go down means dollars lost. But in a kind of a disaster recovery or disaster preparedness situation, having your application be down can actually affect the livelihood of the people that are affected by that disaster. So it's more than just dollars and cents. It's actually kind of a real world situation. So high availability and making sure that your applications are always running is really important. In addition to high availability, basically just means having more than one instance of your application running. In case one instance goes down, you always have something else that can process requests. But auto healing is another important thing that kind of is a part of that as well. Like if your application fails, what actions can you take that you can take to automatically bring up that application back up? Kubernetes handles that out of the box, and that's one of the things that we're going to be talking about today. Orchestrating different kinds of applications. If you're collecting different kinds of data, you want to be able to share data between applications, make decisions, and then just basically orchestrating all of those different components together can be really challenging because you need to have things like service discovery and hopefully something like DNS. So, Kubernetes, again, it's kind of out of the box, solves this set of problems, and we'll definitely take a look at that. So, diving into Kubernetes, looking a little bit more at the architecture and the nomenclature. Some of the kind of the high level nomenclature here. A pod, you'll hear people who talk about Kubernetes, they'll talk about pods a lot. A pod is the smallest unit of deployment in Kubernetes, and it's the thing that's running. It's the thing that's running in that Kubernetes cluster. Typically, you have one container to a pod. You can have more containers. You can have more than one container to a pod in a scenario where you have containers that are tightly coupled, and that's called a sidecar pattern. Worker nodes are the things that run the pods. They get scheduled workloads. They have a Docker engine running on those nodes, and basically they schedule or they run the containers for your applications. The master node is the thing that delegates out to the worker node what workloads need to be executed. So together, the master node and the worker node work together to make sure that your applications are running, and your applications are running in the form of one or more running pods. So an architectural view of exactly what I just described, if you start on the right side, you have all of the worker nodes that have the Docker engine installed, and those are going to be running your pods. and also be running your containers within those pods. Those worker nodes have direct access to an image registry. So that's going to be the IBM image container registry, or if you're familiar with Docker Hub, that's kind of the default public registry that you can get started with when you're first starting to use Docker. So those worker nodes are going to have access to pull images from that registry and run images from that registry. The master node or the Kubernetes master is receiving requests from the API. And so on the very left side, you have the user interface or CLI. It doesn't really matter. The API is it's like a REST interface, and you can interact with it in a number of different ways. kubectl is what I'm going to be using mostly for the demo today, which is the command line interface tool to interact with the API. And that we're going to send a request basically through the API to the master, and then that master is going to be scheduling applications onto the worker node. So that's kind of the basic flow. Zooming in to the Kubernetes master, there's a couple of really important components here that we should be talking about. API server basically exposes that endpoint for you to send requests using the kubectl command line tool to send requests to Kubernetes. Hey, I want to deploy this application. The etcd database is the component that really drives the whole Kubernetes cluster. So the way Kubernetes work, it's a declarative model. So you can think of it as like CRUD operations. You have different Kubernetes resource types that you can create. You say, I want to create this resource type, and you send that request to the API. The API server stores that data into the etcd database. And then you have schedulers and controllers that are looking for changes in that database and will take appropriate action to affect change onto the cluster, whether it be for scheduling new pods on the worker nodes, for example. So these are, when I say CRUD, CRUD operations with different types of resources. These are some of the resources that I'm talking about. We have the items that are in bold are probably the most commonly used, but you can see by the plethora of different resource types, which is not meant to be intimidating. I honestly don't know the intimate details of every single one of these resource types, but it comes up on a use case by use case basis. Basically, if you want to do something, you figure out what resource type you need to do it, and then you create that resource type. So there's a number of resources, and there's a resource for every purpose, every use case that you'd want to do within Kubernetes. So deployments, pods, and services are the things that we're going to be talking about most today, and we'll be seeing that in the demo. So let's take deployment as an example. A deployment is basically inside of a deployment, you say, this is the application that I want to run, and you specify the Docker image, like the image tag, and then you say how many replicas you want to run. So that's a deployment. And what I want you guys to think about that as we work through these scenarios for how Kubernetes works. What is the workflow of creating a new deployment? So scenario number one is we want to create a new deployment. kubectl create deployment.yaml, and that YAML file will have our deployment and all of our configuration that we want inside of that YAML file. And the process, the way it works, is that we create this deployment YAML file. It does some checks and makes sure that your YAML file is syntactically correct, and makes sure that all of the keywords are there, the things that it's expecting. It also makes sure that there's no resources with the same name, naming conflicts, things like that. So after it does all of those checks, it writes a resource to the etcd database. And then the controller processes that are running as part of the master are watching that etcd database. They recognize that data has been changed in the etcd database, and they realize the actual state of the cluster, which I'm monitoring, does not match the desired state of the cluster, which had just been updated because of that new deployment. So the controllers will basically do a loop, and they'll do a loop and take action to resolve that discrepancy between actual and desired, and they will take the appropriate action to make actual be equal to desired. So in this case, deploying a new deployment, it's a matter of scheduling new pods for that deployment. Now, if you take the same process and you apply it to a different scenario, so this is auto reconciliation or a self-healing scenario where, let's say, something bad happens, your application goes down, maybe a node in your cluster goes down and takes out many pods for different applications. Actual state is updated. The actual state is updated, and the desired state, which has not changed, those two things no longer are equal. And the controllers, they take the same action. They recognize that actual state does not meet desired state, and they will try to reschedule those pods on other available nodes to rectify that situation. So the reason I go through this process of like how this actually works is like it's auto healing, and this auto healing and auto reconciliation is built in by design. That's actually how the Kubernetes orchestration platform works, and you can have a lot of trust in that design if you understand it, and you know that the auto healing is going to take effect when your application goes down or something wonky happens to it. So diving into the worker side, so we dove into the Kubernetes master side, but on the worker side, its main responsibility is to schedule the workloads. It's going to run a number of pods. Each one of these pods is going to run one or more containers within that pod. It's going to have access to the image registry because that's how it's going to pull your containers down and run them. These worker nodes are going to have the Docker runtime that it's running, because that's what we need to run those containers. It's going to have a couple other processes to help make this whole thing work. A kubelet is essentially is a process that communicates back to the master. So you can think about reporting container status or receiving requests to schedule new pods. That's what the kubelet process is for. Kubeproxy handles the networking. If you have 10 replicas for a deployment, those replicas might be spread out across a number of different worker nodes. So you need some kind of virtual networking layer so that when this worker node receives a request, it has some kind of table so that it can look up basically where a request should be routed to, what underlying pod and container should this request be routed to. So that's what the kubeproxy's responsibility is. So we talked a lot about Kubernetes and call for code, making things highly available, scaling on demand, and then orchestrating different types of applications together. This is kind of your comprehensive list of the value add of Kubernetes. And it has to do with building applications across distributed clusters. If you have multi-workstation, if you have multiple nodes in a workstation, it's a good idea, especially if you care about high availability, to have more than one workstation in case you have a machine that goes down. Even with cloud resources, it's good to have more than one VM provisioned, so you can always ensure high availability for your applications. So, considering that you have this kind of distributed problem where you have to deploy your applications across distributed nodes, then you have to have things like scheduling, intellectual scheduling, just making it easy. Tell Kubernetes, I want to deploy this, and Kubernetes will automatically figure out which containers should be scheduled across which of the worker nodes. Self-healing, we talked about that a lot already. Horizontal scaling. Scaling on demand is manually, it's incredibly easy. There's a one-liner, which I'll do in the demo today. It's extremely fast to scale. But you can also hook it up to like CPU usage. If you get to a certain like 70%, 80%, that's totally determined by you, of CPU usage, you can automatically scale your application and create more replicas in scaling horizontally. Service discovery load balancing for distributed applications with a number, or if you're scaling horizontally, you have a number of replicas, you need some kind of virtual IP in front of all of that stuff and a load balancer to be able to route traffic to any number of your like underlying replicas. And that's built into Kubernetes with Kubernetes services, which is something that we're going to show in the demo. Automated rollout and recovery. If you need to update your application, can you update it without taking the application down, and that's built into Kubernetes by default. And then secret configuration management, if you have to configure at runtime, maybe you need to inject secrets to a database or apply environment-specific configuration. There's built-in constructs for that within the Kubernetes environment. So just real quick, this is the Kubernetes. This is the same slide I showed before. I'm gonna show you an example of deployment, a deployment and a service here, and this is kind of all mushed together. But you can still see the text. We have a deployment type here with the number of replicas, and this is where we're specifying our Nginx image. And then on the service side, we're saying this is a kind service, and it's a type node port, which means it's exposed publicly on every worker node in the cluster, and that's the kind of thing we're going to do in the demo today. And the selector is very important because this is how different objects in Kubernetes talk to each other. It's a selector and label mechanism. So you have a selector at my app, and then you have labels that you apply, labels at my app, and basically that's how you connect two things together. You give your containers the at my app label as specified by this template section, and then you can build a service on top of all of those containers or all of those pods using this selector at my app. So that's how all of the different resource objects that you create in Kubernetes can find each other and talk to each other. All right. So one last thing before we get into the demo. So Kubernetes is an open source project. It is part of the Cloud Native Compute Foundation. It's very community driven. A lot of active contributions going on by a lot of really big companies in the industry, including IBM, for open source contributions. But it's actually, it's not really recommended to manage yourself, because when you have, it's an open source project, so you can download it, you can get your cluster, and you can install it. But there's a lot of things that you need to manage, such as patching the underlying nodes to make sure that they're secure, setting up all of the networking policies. You need to set up the networking so that Kubernetes will work, because it requires certain ports and things to be open between the nodes, but you don't want to expose too much, because you're opening up services for attacks and from a security perspective. And then just general security, just making sure that everything's tightened down and you're not exposing any vulnerabilities that people can take advantage of, especially when it comes to personal information. So there's no reason to not take advantage of click to deploy Kubernetes services. So IBM has a IBM Cloud Kubernetes service. It's click to deploy. You select how many nodes you want, and then you can deploy it. If you are interested in a non-cloud workstation local installation, we have IBM Cloud Private Community Edition that you can use an installer to make use of an installer to install that across your local workstations. From IBM's point of view, both IBM solutions are 100% open source Kubernetes, and so we don't put anything in front of it. Everything you do with those solutions is just Kubernetes, and Kubernetes is Kubernetes. You can take your Kubernetes stuff and go anywhere with it. We definitely think that's really a really valuable point to point out. So without further ado, I'd like to get into the demo here. We're going to deploy a React application onto the IBM Cloud Kubernetes service. And what I'm going to do, actually, this is a pattern that you can find on the Call for Code website. So this is the Call for Code website. If you haven't seen this page yet, under resources, you can find a number of different code patterns that could help you basically jumpstart or maybe just give you ideas for your applications. It's also a good way to get your hands dirty with a new technology that you don't necessarily have experience with. So that's kind of what I was thinking about for today. This is the code pattern that I want to deploy React application on Kubernetes. Follow the links. Eventually, you will get to a GitHub project, which I have open here in another tab. So this is the GitHub project associated with this pattern. And so I encourage you guys to go through and walk through this on your own. I'm not going to kind of read out loud everything in here, but I'll go through kind of the basic architecture of this application. And it's really simple. We have a React application. It's running inside of a Docker container. That Docker container is running within a Kubernetes orchestration platform. So we can do things like scale and auto healing and making sure app is always available. All those benefits that we talked about is brought by the Kubernetes platform that we're deploying on. This application basically gives you things for movies. So it uses this OMDB, it's an open movie database API, where you can send it requests, like give me information about a movie, and then it basically just returns it in JSON. So that's what this app does. The user can search for the title of a movie, and this application will call the OMDB API, get the information about the movie, and then show that to the user within the React application. So, there's a lot of cool things on this GitHub page. There's a demo on YouTube. If you get stuck, you can follow the demo of someone actually walking through it. Prerequisites: you need to go to OMDB to get a API key, which is free. And you just click on here, you click on API key, you give them your email. There's obviously a limit for how many requests you can do, but if you're just playing around with this example, totally fine. And then you want to insert your API key into this index.js. So I've already done these steps. I have my API key in there already. But if you're doing this on your own, you're going to want to do that. Step 2 for the prerequisite is export this environment name for my Docker username. So this is just going to make it easier to run the rest of the commands. Let's see here. So I'm going to run that. But instead of your Docker username, I'm going to put in my Docker username, which is Zaccone. Okay, so I did that. So the first thing we can do is we can run this locally. And basically, this project kind of steps you through it step by step in terms of abstractions. So, the first thing I'm going to do is clone the repo. I already did that, but you can clone the repo locally to get started. So you have all the code locally in your workstation. And then, so the first level of abstraction is not using Kubernetes, not using Docker, using Node to run this application. So you can install Node, you can do npm install, to build the CSS, and then run start. And you can do this to verify that your Node application works by itself without introducing Docker. I encourage you to go through that on your own. I'm not going to do that. I actually don't know if I have the right Node installed to do this. And one of the great things about Docker is that I don't need to have Node installed, especially, because that Node dependency is going to be contained within that Docker file. So that's what I'm going to be relying on to run this locally at first. So I'm going to skip ahead to this section, run the application using Docker. Let's see. So the prerequisites, I have a Docker account already. I have the Docker engine installed, and I have the Docker user ID, which I use in the export command. And I can run this Docker build. Okay. And it references that Docker username variable, so I don't have to change anything about this command. It will automatically work. I ran this before just to save time, so you can see I'm already using the cache here from it being existing already on my local workstation. All right, so if we go to the next step, we should be able to verify that our image has been built using Docker images. I'm gonna just do a grep for React, just so you guys don't get to see all of the images that I have on my system. But I have this deploy React Kubernetes. 4 hours ago was the last time I built it. This doesn't count because the image already existed. Okay, so before we run in Kubernetes, we can verify and run it locally to make sure that it works. So let me clear my screen here. So this is the command that we can do to verify that it runs locally. Exposing port 3000, which is the port 3000. This is what this React application uses. And with that running, I can go to my browser and do localhost 3000. And I should be able to see the movie finder application, and it works. So it works locally. So now we're ready to move on to deploy to Kubernetes. So I kind of realize I'm glossing over a lot of the code and the details. So let's take a step back and actually look at some of the stuff that's actually exists for this application. So I have it open in Visual Studio Code, and I'm not a React developer. I actually, don't know very much about React at all, but I'm able to follow a tutorial and deploy this application using Docker and Kubernetes. The thing that I really want to see is this Docker file. If I can find it, here it is, Docker file. So you can see here that these are the dependencies for this application. It's using Node version 9.4. It's running npm install to install those Node dependencies, specifying the port, exposing port 3000, and then the execution for this application is running an npm start. So the only information that I really care about is contained within this Docker file. What are the dependencies? What is the port that I need to expose, and kind of the details on that regard. So, so this is the Docker file that was referenced when I built the image, and then when I ran the image, it basically is running. It's running npm start with all of these dependencies already installed within that container. All right, so back to the README. The next step, since it's working locally and we validated it locally, we can move on to running our application on Kubernetes. So the first thing you need to do to get your application running in Kubernetes is you need to publish it to a registry that your worker nodes have access to. That's how this whole thing works. If you publish to a registry, and then when you tell Kubernetes, this is the image that I want to deploy, Kubernetes will look at your image, and you should have your registry information as a part of that image, and then that's how your worker nodes know where to find that image, pull it, and run it. So we have to get that image into a central registry. So for this demo, we're going to use the IBM Cloud Container Registry. So there's some prerequisites. You need to log into IBM Cloud CLI. You need to install the Container Registry plugin. So I already did all of those steps. In addition to getting your image into the registry, you also need to create a cluster. Excuse me. You need to create a cluster. You can use the CLI, IBM Cloud CS cluster create, or you can log into the IBM Cloud Console and you can create a cluster from the console. So this is what I've done here. You do need a pay-as-you-go account, but once you have a pay-as-you-go account, you can create a free one-node cluster and play around with it and do stuff. So this is my one-node cluster. I can go and get different information about it, and all of this information is accessible through the IBM Cloud CLI as well. So depending on how you want to work, if you like the user interface or the command line, you can use either one. All right, so we created a cluster. I already have the cluster created, and we need to configure our Kubernetes client to talk to that cluster. Another prerequisite is to have your Kubernetes client installed, which I think is actually here. It's number 6. You have to install kubectl, which is a Kubernetes thing. If you want to use Kubernetes, you need to install kubectl. So you might as well go ahead and do that. And then once you have kubectl, you want to configure it to talk to the cluster that you're using. So if you're using IBM Cloud, you want to run this command and put in the cluster name here, demo cluster. And basically, this just spits out a configuration, just in a second, that you can copy and paste, and it's export kube config. So basically, this just tells the kubectl, which looks for this kube config environment variable. It tells it about your cluster so that you can talk to it. You can verify that it's connected to your cluster by doing kubectl get nodes. You can look at this IP, .143. If I look over at my cluster, I can see .143 is a private IP. So that's how I know that it's properly set up. Okay, so I configured my kubectl. And then the next part is adding your image to the container registry. So I've done a lot of this already to save time, and I can show you the result of running all of these steps. Basically, the steps are you want to do IBM Cloud Container Registry build, and then you want to build your application with a given region that you're deploying to and the namespace that you created in step 9 above here. If you follow these step by step, I swear you won't miss a beat, and it is really straightforward. So let me show you that IBM Cloud container registry image list. So this will show you the image that I've already built. Sorry, not that one, this one. I've already built. I pushed this to my namespace that I created called JZ namespace. And this is my deploy React Kubernetes. So this is the image. It's in my container registry on IBM container registry. And that's all I need before Kubernetes running on the IBM Cloud in order to be able to pull this image and run containers from this image. So with that set up, we can move on to actually deploying your application onto Kubernetes. There's 2 steps to do it. You can do kubectl run, which is it's just an abstraction. Instead of creating YAML files, you can do kubectl run, and we'll actually create those YAML resource files for you without you having to like line by line create those YAML files yourself. But this project already has a deployment.yaml file included within it. So the easiest thing for me to do is just to do kubectl create and create that or pass in that deployment YAML file that already exists. So let's look at that deployment YAML file. And the service and deployment example that I showed earlier in the slides, this should be very similar. We have 2 resource types here. We have a deployment and we have service. The deployment references the image that we want to use. This is the image that I showed you with the registry name, the namespace, and the name of my image. The container port 3000, and also specify the number of replicas. We can just start with 1 and then auto scale it up later. In addition to our deployment, we also have a service. The service basically provides a single IP in which we can expose our application publicly, and then it acts as a load balancer to route to all of the underlying replicas in our deployment. So with replicas 1, it's really not that interesting. Every request will go to that single replica, but you'll see later when we scale up, really what the importance is of having a service and a load balancer in front of your deployment. So the key thing here is this selector. This is how it knows which pods to route traffic to. This selector is just app, and then you can see under the template for the deployment, we apply the labels app. So that's how these 2 different resource types can find each other. In this single YAML file, we have a deployment and a service. You can easily pull it into different YAML files if you want. It's totally up to you. If you want to put more than one, you can just separate it with some dashes here, and kubectl will be able to parse through either of those. So let's deploy this deployment file. So we do kubectl create deployment.yaml, and you can see our service was created, our deployment was created. We do kubectl get pods to see the single pod that we have, the single replica that we have running. And kubectl get service will show us this is our service that we exposed, type node port, and it's running on 30,080. This node port means that it's publicly available on every worker node of the cluster. So what we want to do is we want to use this IBM Cloud command line to print out information about the workers we have in our cluster, IBM Cloud CS workers, and then the name of our cluster. This will give us the public IP. By the way, I can just get this from the console too. It's probably way easier. But this will give me the public IP. And then if I combine this with a 30,080, that is the information that I need to gain access to my Movie Finder app. So I can go here, and there it is. There's my Movie Finder app running on IBM Kubernetes service. Finding Nemo, and just to verify that it works with other movies as well. You can type in any movie here, and it'll pull the information. So maybe one last thing is, if we wanted to scale our deployment, it's really easy. You can edit the YAML file and update the deployment, or you can use this kubectl scale command. You specify what deployment you want to scale, and you specify the number of replicas. So we can run that. We can run kubectl get pods, and you can see that Kubernetes is automatically scheduling all of those pods. It's container creating, but if you refresh again, it takes a little bit to download the image the first time, but all those pods will eventually be running, and you can see that they're slowly updating one at a time. Let's see. Once this is running, then let's do something crazy, and let's delete a pod. So what's going to happen is this is going to trigger auto healing. And if we do get pods, this is terminating. But you can see that there's one that was created 3 seconds ago. I believe that's the one that was, yeah, you can see, because there's nothing here that's 3 seconds. But this was created 3 seconds ago. So that was actually created in response to me deleting that pod. It automatically recovers to that 10 replica state that I declared when I scaled this deployment. So that is your React demo. You can always go to the code patterns on the Call for Code website or developer.ibm.com and find different examples of how to run different applications with Kubernetes. I hope you guys learned a little bit about how to use Kubernetes for your Call for Code applications and the value that depends there. And yeah, thanks for tuning in.